Hello, my name is Alex Balcher, and I'm a senior engineer with Materials Sciences LLC. I'm excited to share the details of our Small Business Innovation Research Phase 2 program entitled Radar Absorbing Material Maintainability Improvements. A little bit about Materials Sciences. We've been in the composites industry for over 50 years. We are headquartered in Horsham, Pennsylvania, just north of Philadelphia. Our projects span from cradle to grave, including design and analysis, material characterization and prototyping, all the way through to production manufacturing. We operate a total of 45,000 square feet in Greenville, South Carolina for specialty textiles and composite production, as well as a 12,000 square foot manufacturing and engineering facility in Huntsville, Alabama. As you can see, we have a wide range of capabilities and many examples of successful product transitions. MSC is pleased to have been awarded an opportunity to work on this Navy challenge, which focuses on developing a new and improved environmental protective layer for the radar-absorbing material on Navy assets. These RAM tiles are integral to low radar signature of various assets, but are often not intrinsically resistant to exterior environments. The current environmental coating does not meet the Navy's desired lifespan and is no longer being produced. Our goal is to produce a replacement environmental layer that exceeds the objective lifespan, reduces installation costs, while meeting all environmental and functional requirements. The target metrics to achieve this goal are shown in the table. Let's talk a little bit about why this project is important. For operational use, the environmental layer needs to remain intact to protect the underlying RAM material. Some comparable materials are no longer being manufactured. The current protective coating suffers from a variety of limitations, including high initial cost and requiring frequent replacement, which is complex, and the lifetime of the replacement is not yet fully known. These limitations stem from the layer-based material being a thermoplastic film. While this is generally a robust protective material, thermoplastics are typically difficult to bond to without advanced surface preparation of the RAM substrate. Repairing the environmental layer is costly, requiring the ship to be in depot and serviced by well-trained technicians with a complex, skill-sensitive procedure. And, as previously mentioned, the current environmental layer is no longer being manufactured to support repairs. When you think about a depot-level repair, there are lots of different considerations such as the adverse effect on mission readiness, the time to repair, the labor involved, and the downtime of the asset. MSC's technology can cut down these adverse effects by a factor of 4 at a minimum. That's why this new innovative environmental layer is so crucial. We're extending the lifespan by improving the peel strength saving hours in the repair process and simplifying the repair process so that the material can be installed by a sailor with limited training, which translates to a significant cost savings. The Navy estimated that the environmental layer accounts for 60% of the total cost of the RAM material. Reducing repair frequency and simplifying the repair process will translate to a significant cost savings. MSC's solution uses a film material that is made from polyurethane resin, which produces a material that can be readily bonded to most surfaces, including most RAM materials, using polyurethane-based adhesives. MSC's permanently bonded polyurethane-based environmental layer enables a longer lifespan while meeting all environmental and functional requirements. The polyurethane coating utilizes hollow spherical fillers to lower the material's dielectric constant. The fillers are shown in the lower right photo taken with a microscope. Materials. Sciences has used this technology for other naval applications to produce low signature and RF transparent materials. There are 2 ways the material can be processed to achieve a variety of thicknesses. The material can be deposited as a 100% solid through a mixing nozzle to produce a layer greater than 40 thousandths of an inch, or it can be mixed with a solvent and applied with a paint sprayer to produce layers as thin as 10 thousandths of an inch and up to 25 thousandths of an inch. Both processes produce an environmental layer that can be provided to the end user in roll or sheet form. Unlike the current repair process, which requires the creation of a smooth, non-porous exterior surface on the RAM material, MSC's material can be bonded directly onto the materials after the damaged layer has been removed with minimal surface preparation. As with any material development, it is critical to plan the technology maturation dates in order to better transition the technology. We fully understand that an excellent technology does not benefit our service members unless it can be produced at the scale. As you can see, Materials Sciences has already achieved TRL3 and expects a minimum of TRL6 at the completion of the currently funded Phase 2 Option 1 effort. If a Phase 2 Option 2 were to be awarded, MSC expects to further the technology to TRL8. Here is a look at the data comparing Materials Sciences' environmental layer solution with the system currently protecting the RAM tiles, highlighting the advantages of MSC's solution. Although we do not have test data for competing Materials Sciences' polyurethane-based layer inherently has significantly better peel strength. The lower dielectric constant also allows for a thicker protective layer to improve impact resistance without changing RAM performance. These mechanical property improvements will lead to longer life and less repairs. Availability is also an important factor as the legacy material is no longer being produced. MSC is planning to conduct field trials in the second quarter of 2026 and has the capability to produce large quantities of parts thereafter as needed. Transition to the fleet relies first on successful qualification by the Navy to verify the coating's ability to work with the RAM material to satisfy the total package performance put forth in the technical requirements, as well as demonstration that the coating protects the material from environmental degradation. When this is proven, the final option of the Phase 2 program, with a program office involvement, will be to demonstrate installation on various platforms and to monitor the performance over a short time period. Following this, Materials Sciences has been told by the Navy that sustainment of the several platforms will be targeted for wider use of the coating and repair process. Regional maintenance centers, naval facilities, and maintenance contractors will be the long-term customers for acquisition of the coating material produced by MSC. In addition to providing materials and support to the fleet, which is a significant market for Materials Sciences given the size of some of the Navy transmission targets, the technology that MSC is developing is a potential replacement for the various commercially made, high-performance coatings, mostly thermoplastic films. What Materials Sciences has invented is a material which has improved chemical bondability to a variety of substrates with a wide range of thickness, hardness, and with various fillers, including fabric, fiber optics, sensors, and heating elements. Current competing materials use thermoplastics that are processed at high temperature and pressure. For 7 years, Materials Sciences has been increasing its polyurethane processing capabilities for multiple DoD projects in addition to the fairly specific requirements of this current effort. These products include sheet production of filled, unfilled, and fabric-reinforced polyurethane elastomers. The process, unlike many commercial elastomer goods production, is performed at room temperature, requires no pressure, and facilitates bonding to many substrates. Materials. Science's specialty polyurethane elastomer can be filled with novel reinforcements and particles to achieve a variety of electrical and thermal properties, as well as sensor and antenna networks. In this way, Materials Sciences seeks to support new capabilities for future naval assets and infrastructure, with a focus on maintainability and maintenance-free performance. Applications for the Army and Air Force seem equally viable, as well as civilian structures in the energy sector and construction. Thank you so much for your time and listening to this presentation. We here at MSC are eager to hear from you. Please reach out to let us know what your needs are and how we can help to transform those material challenges into the solutions of tomorrow.